Well, thank you for coming today. I'd like to introduce Mackenzie Carter. She's one of our graduates. She finished her master's degree here last year in tissue engineering, working on a specific idea of a tissue test system for panosteitis. She is currently working as an intern at the Smithsonian Institute. I appreciate that she's taken the opportunity today to tell us about citizen science and the potential for using citizen science in what we do. Mackenzie, thanks.
All right, thank you. So welcome today. So like Dr. Berg said, we're going to talk about citizen science and how it can be applied to teaching STEM courses. So citizen science broadly is just the involvement of community members in the acquisition of knowledge and in conducting research. So some of the core tenets of citizen science is that anyone can participate, so you don't have to have previous science experience or research experience. The idea is that when you create a citizen science project, you want to have a protocol that anybody can follow. And part of that is making it easy for volunteers to participate and making it so that your protocol is understandable by anyone who does want to participate. Another core idea is that the data that citizen scientists collect is real usable data and goes towards real research that will be published in research publications. And lastly, the idea behind citizen science is that it's really a partnership between community members and scientists. The scientists get benefit from having community members involved, and the public engagement aspect for the community is really important as well. So one thing that we try to quantify in citizen science projects when we're understanding how well they're doing is public engagement. And so that's understanding and trusting the scientific process. It's also whether or not participants have a scientific identity, whether or not they can see themselves doing science or participating in science. Not just whether or not they can memorize facts about a project, but whether or not they see themselves as contributing to a project. We also find that citizen science helps participants have a stake in public policy that affects research and things like environmental policies. For the researchers, citizen science benefits them by making it so that they can collect extremely large data sets. Data sets can be over large geographic areas, over long spans of time, can require a huge amount of work in order to gather these large data sets, but in the end that helps the scientists have a higher statistical power in their analyses, which makes it so that the research can be applied more broadly and to better effect. So when you're choosing a citizen science project, there can be a couple of ways to do this in a classroom. One of the ways would be for the professor to choose the projects and then give students a particular project or a sample of projects to choose from. And that way the professor could tailor the content to the class and control the quality of projects that are involved in the class. The other way to do it would be to allow the students to choose projects. And this way the students could follow their interests and potentially have involvement in the project after the class has ended. So one of the ways that we can look for projects and get started is through a website called SciStarter. And SciStarter is basically a citizen science aggregator. You go to the SciStarter homepage, this is what it's going to look like, and then over here it says find a project on the right hand side of the screen, and you can enter your location. So these projects are worldwide. A lot of them are located in the United States, but really you can find projects all over the world. So if we say Athens, Georgia, and let's say we're looking a biology project. And so you can see they have chemistry, they have climate and weather, you can do geography or earth science, health and medicine. There's a really wide range of projects that you can choose from. So we're going to go try and find a project. So over on the right-hand side, you can see that there are 260 projects that you can do in Athens, Georgia. From Georgia Adopt a Stream, which is run by the county and the state, or the American Chestnut Foundation, where you can track chestnut trees and stuff like that. So if you wanted to further narrow down which projects, you can say over on the left-hand side, I want to do this project at home. Or I want to do a project that can be done outdoors. Well, that doesn't make sense. At home, outdoors. Let's do at night. And I want a project that can be done outdoors. So there are a whole bunch of different ways that you can narrow down which projects will be shown to you. And so if we say find projects, we can take a look at bugs in our backyard. And SciStarter will give you information on each project. Each project is vetted by SciStarter. They have people that go through and make sure that these are legitimate projects and that they follow SciStarter's rules as far as citizen science projects go. So SciStarter will tell you who the project is run by, in this case Colby College. They will tell you the goal of the project and give you a description. They will also tell you when the project happens and what the commitment is for the amount of time that you need to put in if you become a participant. And so they have plenty of information about perhaps ideal age group, the frequency of when you need to check in and things like that. So SciStarter is a really great tool to find projects in your area or around the US. But when we're thinking about choosing a citizen science project for a class, there are a couple things that we need to consider. So when you're choosing a project, we need to think about why we're incorporating citizen science into the classroom. And that will inform which projects apply best to what we're trying to achieve. So is the project data collection, data categorization, or is it both? Can you go out into nature and take a picture of a plant or an insect and put it into the database, or are you identifying said insect or said plant and doing that all online? What is the level of involvement? Does the project need you to check in every week with new data? Is it a one-time thing? How much involvement are you going to require your students to have? What is the duration of the project? Some projects are once a year and they do a huge data collection, perhaps in the fall, and then that's it for that year and they will do it again next year. Some projects are ongoing and have data collection every day of the year, all year long, for multiple years. Where can this project be done? Do your students need to be able to get to particular sites? Can they do it from home? What are the barriers to your students participating? Additionally, on that same vein, is there a phone app or do you have to put in data online? So do you have to be able to record the data and put it in online later, or can you use your phone at a remote location? Do you need equipment? Some projects require specialized equipment, and I will go back to that later, but that's something to think about in order to make it easy for your students to participate. Additionally, who do you call for questions or troubleshooting, or if there is a safety concern? These are all things to think about before you get started on the project. Oh, And does it cost anything to participate? I'm sure your students would not like to find that it costs them additional $15 to do this project. And lastly, one of the things that's good to think about is whether or not the project allows your students to continue on in the scientific process. A lot of projects are just data collection, which is like inserting yourself into one step of the research process, but maybe once they've collected the data, they want to see the big picture. They want to have access to the data and perhaps do their own analysis for a research paper. So do you have access to that data from a particular project? Additionally, do you have access to papers written about that project? Perhaps they can see what people have concluded from the data that has already been collected. So I mentioned that some of the projects may require specialized equipment. One of the ways around that I have seen is to partner with the library and put together kits of equipment that is needed for the project so that students can go rent the kit from the library and then bring it back rather than having to buy their own equipment. And it can be anything from as small as test tubes to gather soil samples, or like photographic equipment so that they can take high quality pictures. So the library, I know the UGA library has resources for technology lending, for cameras, laptops, that sort of thing. But they also have data analysis software, so if your students want to take that next step with the data that's available to the public, that is a resource they can call upon. So here at UGA, there's already a couple projects that are going on. There is Project Monarch Health, which tracks the spread of a parasite among monarch butterflies. And so what they do is once a year they will teach participants how to handle the butterflies and make an imprint of the butterfly abdomen on a piece of paper so that they can see if it has parasites or not. Additionally, the Great Georgia Pollinator Census tracks the different types of pollinators in Georgia, and that is also a one-time a year project. And then the Marine Debris Tracker from the College of Engineering is a app that you can have on your phone to document and then remove pieces of marine plastic from the environment. So these are projects that are already happening at UGA. Perhaps they would be good places to start for partnerships with projects, get students more involved, and kind of open up the field for citizen science. So in conclusion, citizen science is real science. The data that is collected is used in real research. It gets published. It goes into policy decisions. It has a real impact, and people who are involved can have a sense of contributing to the bigger picture. Citizen science benefits both researchers and participants. And then in a classroom setting, projects can be chosen based on the class content, so tailored to that, or based on student interest, and then the different participation requirements and what the teacher seeks to get out of the project. And finally, there are resources available to complete projects, such as using the UGA library. So that is my spiel on citizen science. Thank you for being here today.